Good morning, students. Welcome to KUTV Elimu Live. Our lesson in mathematics today, we are looking at the topic trigonometry, but we have a small section where we'll be looking at trigonometric graphs and their solutions. For Form 4s, they will understand where this is best. Again, Form 3s have also some bit of it because it starts from Form 3, and then we finish the drawings of graphs in Form 4. And we will be analyzing only 3 parts on this subtopic. One of it may not really require us to draw the graphs, but we shall have to interpret trigonometric graphs and get out 3 important things. Understand what's the amplitude. Then we shall need to understand what's the period of a graph. And number 3, we shall need to understand what is the phase angle. Those are 3 subparts that we need to understand when drawing trigonometric graphs. But then what we mean by these trigonometric graphs are graphs that are drawn out of trigonometric ratios. And mathematics gives us 3 basic trigonometric ratios that we teach in secondary schools, and these ratios are the sine, the cosine, and the tangent. So those are the ratios that we shall be focusing on and see how we draw the graphs that are related to these trigonometric ratios. Then we'll then finish up with waves. Wave functions are drawn in Book 4, that is Form 4, Topic 3, under Trigonometry 3. And then once we've drawn the waves, we shall get out what we call the period, amplitude, and the phase angle. So welcome to our lesson, and I hope you are ready with your ruler, because this is a graph work, and you have your graph book ready with you so that we can all draw the graphs as required. And so the first thing that we want to do is to review what happened in Form 3 is that you are able to draw, we are able to draw the sine graph. The sine graph, that is, for example, y is equal to sine x. The graph of y is equal to sine x is drawn in Form 3 under Trigonometry 2. And this graph, as you realize, is that it has both the maximum and the minimum points. And then the maximum, we talk of the maximum, is always equal to +1, and its minimum value is always equal to -1. And therefore, that tells you that the graph of y is equal to sine x, above the x-axis, it has a displacement of 1, and below the x-axis, it has a displacement of -1. That then attributes to what we call the amplitude. Now, if I do a sketch of the sine graph, this is the x-axis, and then the y-axis, the point 0, and this is 1, this is -1. So we can have this as 60, 120, 180, 240, 300, and 360. And those are degrees. You realize that the curve will run this way. That is how the sine graph will run. And as you can be able to see, the maximum value is +1. This is what you are calling the displacement of this wave. This is the displacement. And this displacement attributes to the first thing that we've said. We are calling this one the amplitude. This is the amplitude of the graph. Again, below the x-axis, it has an amplitude of -1. But we don't take the negative value, we take the absolute value of x. So that is how the sine graph of y is equal to sine x will appear when you draw to scale. And then you are again able to draw the cosine graph, and the cosine graph now appears this way. The cosine graph. In this case, we are saying y is equals to cos x. Again, it takes the same principle of the sine graph, but this is how it will appear with 0, with 90, with 180, with 270, with 360. Then we have this as 540, and so on. This is the x-axis. This is the y-axis. The highest point is 1. And again, the lowest point is -1. But now, when you draw the cosine graph, what happens is that it starts at the highest point, and then drops. It starts at the highest point, then drops downwards through 90 degrees, and then turns. And so that's how it moves. This is the cosine graph. This is the cosine graph. And in this case, y is equals to cos x. Again, you'll realize that the maximum point is +1, and the lowest or the minimum point is -1. These are graphs of sine and cosine of x, and they are drawn in Form 3 under Trigonometry 2. Then we have the third kind of graphs, what we call the tan graph. The tan graph. And in this case, y is equals to tan x. Y is equals to tan x. Now, a tan graph appears differently from the cosine and the sine graph. And for this graph, it has no maximum and minimum. This graph has no maximum and minimum. It has no maximum and minimum. That is for the tan graph. And this graph is discontinuous. This graph is discontinuous. At the values of x equal to 90 degrees. The value of x equals to 90 degrees. The value of x equals to 270 degrees. The value of x equal to 540 degrees, and so on. In short, it is discontinuous at the value 90n. And in this case, where n is an odd number. So the graph of tan is not a continuous graph, as we can see in the sine and in the cosine graphs. And the reason why it is discontinuous, or why we say it is discontinuous at this point, is that these values attribute to what we call asymptotes of the graph. And that's why the tan graph are usually referred to as the asymptotic graphs of trigonometric ratio tan. And so what we mean is this: if you draw a tan graph, y is equals to tan x, then this is what we shall have. This is the y-axis. This is the x-axis. This is the point 0. Then we have this value. Let's take this as 45, 90, 135, 180, 225, 225 plus 45, 270. Then we have 315, 360, and so on. So at 90, the graph is asymptotic. So we represent that using a dotted line. We draw that using a dotted line. It has to be straight to illustrate the asymptotes. Again, at 270, the graph is asymptotic. So we shall draw again a dotted line. And if the graph will continue up to 540 degrees, we shall as well draw the asymptote. So this is how the graph will rise. It rises. And then at this point, it starts from the lower point and then rise. At this point, it rises again in that form. So that is what we call the asymptotic graph. And so when you draw them, you have to be very careful so that you don't find it wrong. This is an asymptote. And how you realize, those who are using calculators, how you realize that there is asymptotic point is when you find that the value of tan x is, it gives you a math error. That means that that point is discontinuous. So those are foundations of graphs that we drew in Form 3 under Trigonometry 2. And these graphs were again used in solutions of different questions on graphs in the same Form 3 work. But now, my focus today is to look at the graphs that we draw in Form 4, what we call the waves, or the wave graph functions. And they are just the same as these graphs, only that the interpretation is a bit different and the nature of questions that we solve using the wave functions are different. And so we are going to handle three things. We're going to handle three things. One, we're going to handle amplitude. Amplitude. And when we talk of amplitude, we need to know what is amplitude. And this is the maximum displacement. This is simply the maximum displacement above or below the x-axis. Above or below the x-axis. The maximum displacement of the curve, either above or below the x-axis, is what we call the amplitude. However, we don't take the value on the x-axis, but this is given by the value on the y-axis. It's given by the value on the y-axis. If we can draw a sketch of a wave, this is what will happen. Ensure that your lines are very straight. And so we have this as the y-axis, and this is the x-axis. We have the point O. So if I draw a graph, for example, sine is equals to x, this is how it will appear. That is the graph. This graph has a value above the x-axis, which is 1, and below the x-axis, which is -1. So this is what you are referring to as the displacement or the amplitude. This is the amplitude. And so we give the value that is positive. So if you find your graph is below the x-axis, it will give you a negative value for the amplitude. But we don't take the negative value, we take the absolute value of the value on the y-axis. So that becomes the amplitude. Number 2, we are going to discuss and see how to identify the period of a graph. How to identify the period of a graph. And in this line, we will need to know that when we are discussing the period, we'll see the number, or simply the time taken to make one complete oscillation. That is how we define period in physics. It has the same relation to what we understand or analyze in mathematics, but now we look at the angle that is taken to make one complete cycle, because here we are dealing with angles. Unlike in physics, when you're making now revolutions, we deal with the time, and so the period becomes the time taken to make one complete oscillation. Here we are looking at how the circle makes, the angle that the circle will take to make one complete cycle, or for it to repeat itself. In case for a curve of this kind, if this is my x and this is my y, then I have 0. Let's put here 180, then put here 360. So if I have this curve turning at this point, then this way, then when we stand at this point, by the time we get to 180 degrees, we shall have made half of the circle. And so another half is from 180 to 360. Therefore, this curve or this wave has a period of 360 degrees, because that is the angle that we've taken to make one complete cycle. Number 3, we're going to see what is called the phase angle. The phase angle is simply the angle difference. You'll find that some of the waves will be given in the case, for example, y is equals to sine ax plus b. Sine ax plus b degrees. And then what we call phase angle is that angle difference, which is in this case b degrees. The angle that is either added or subtracted to the main angle is what we are calling the phase angle. And so with the 3, it is important to know that we might not necessarily draw the graphs, because some of the questions in this subtopic will either require you to calculate or they will require you to draw. If you are given a question in section 1, it will really be about calculating, and then in section 2, we might really require you to draw. So if you are given a question on this 3 that requires you to calculate, how do you calculate? There is a principle or a formula that we adopt. So we have determination of amplitude, period, and phase angle, without drawing the function. So if we are given now a function, if we have given the function y is equals to a sine nx plus b, or y is equals to a cos nx plus b. Remember again, we said it is not going to happen for the tan, because the tan has a discontinuous curve. So in this case, the coefficient of the ratio a, is what we call the amplitude. This is the amplitude. And then when looking at n, the coefficient of x gives us what we call period. And so the period is 360 degrees. We divide by n. And then the phase angle is identified by the value b. Whether b is positive or negative, again, remember to take the absolute value of b, which will be a positive value. So if you find a question in section 1 that requires you simply to determine the period, amplitude, and phase angle, then do not strain yourself. Simply follow the procedure, identify the coefficient of the ratio, and that takes up the part of the amplitude. And number 2, identify the coefficient of x. Divide it by 360, it will give you the period. And number 3, the first angle is simply the angle either added or subtracted to what you are looking at. Practically, if we have this case, you are told to determine the amplitude, period, and phase angle, for each of the following graphs. And the first one, we have y is equals to 2 over 3 cos a quarter x minus 30. That is the first curve. Y is equals to 2 over 3 cos a quarter x minus 30. So the first thing is to identify the coefficient of the ratio. And the ratio here is cos. Its coefficient is 2 over 3. So that is what we call the amplitude. Amplitude in this case is simply 2 over 3. When talking about the period now, period for this curve will be 360 over n. And what is n? N is the coefficient of x. In this case, is a quarter. So it's simply 360. We divide it by a quarter. When you divide it by a quarter, it simply means you multiply by 4 because that's the reciprocal. And so your answer will be 4, 1440 degrees. That is the period. And the first angle will now be the angle difference. And in this case is 30 degrees. That is 30 degrees. So that is how we will identify such kind of values from a question like what we have. If, for example, we have another one, y is equals to 3 sine 2x plus 45. Again, the amplitude should be the coefficient of the sine here. So the amplitude becomes 3. And then the period becomes 360 over by 2, that is 180 degrees. And then the first angle becomes 45 degrees. So that is how we will get such kinds of questions, and usually they are in section 1 of mathematics exam. If that does not happen, then we will be tasked with a question that requires to work out a graph, draw a graph, and then in that case, definitely the marks will be more than 4, and so we shall end up with the 10-mark question. And so I hope you are ready with your calculators so that we can fill the table and draw the graphs. And then I will show you how to solve trigonometric graphs once we've drawn them. So let's see drawing. And I want us to take a simple case. Number 2, you're told number A, complete the table below for the values of y is equals to cos x and y is equals to sine x for 0 degrees less than x less than 360. So we will have our table of values. We'll have our table of values. So if in the first column we have x from 0, 60, 120, 180, 240, 300, and 360. And so we will replace in y is equals to sine x and y is equals to cos x. So you simply substitute in your calculators. I hope my student is ready with the calculator. Y is equals to sine x, that is 1. Y is equals to sine 60, 0.86, round off, 0.87. Sine 120, 0.5. Sine 180, 0. Sine 240, negative 0.5. Sine 300, 1.0. Sine 360, sine 360, 0. Cos x, cos 0. So sine 0, this is 0, sorry, this is 1. And then cos 60, 0.5. Cos 120, negative 0.5. Cos 180, cos 240, 0. Cos 240, cos 300, and then cos 360, 1. Good, thank you. So those are the values of sine and cos of x in our question 1. Part B, and usually the question on filling the table will take 2 marks. That will be 2 marks. Part B, you'll be required now using a suitable scale, draw the graphs of y is equals to cos x and y is equals to sine x on the same axis. And that will give you 4 marks. So in this case, you've been given the option to use your suitable scale. And again, you must be able to know how to use a scale. That is covered in Form 1, topic we call scale drawing. And so with that knowledge in Form 1, you should be able to choose a suitable scale based on the values that you have. The values that we have here, the highest value of y is 1, and the lowest value is negative 1. For x, the lowest is 0, and the highest is 360. At least for that case, there is a range of, there is an interval given. So what we need to do is to draw our Cartesian plane We'll draw our Cartesian plane. Again, we have to be very careful so that we get the right figures. The y-axis is labeled y-axis. Then we have x-axis. And so at this point, we have 0. And so we have to choose an interval that is even. So ensure you take your ruler well and choose an interval. And so let's use a scale of 1 centimeter represents 60 on the x-axis. 1 centimeter represents 60 on the x-axis. That is 60, 120, 180, 240, 300, and 360. So this is 60, 120, 180, 240, 300, and 360. On the y-axis, let's use the scale of 1 centimeter represents 0.5. So we'll have this case. That is 1, 2, 3. 1, 2, and 3. So this becomes 0.5, 1.0, 1.5, negative 0.5, 1.0, and negative 1.5. For the values, what we have is we draw the first graph. Y is equals to sine x. When x is 0, y is 0. So we mark that point. We mark the point 0, 0. Then 60, 0.87. That is 0.9. 0.9 somewhere here. Then 120, 0.5. 120, 0.5. 180, 0. 240, negative 0.5. 300. Sasa hapo mwanafunzi is negative 0.87. That should be negative 0.87. Then cos sine 360. This is 0.87. Then cos 360 is 0. So those are the points we've marked on our graph. And then we need to join them. Ensure you join well at the turning points, because that is what is important. So my curve turns at this point. So I will draw that is my curve. And then we label it y is equals to sine x. Y is equals to sine x. I hope you've drawn, my students, and it should be more better than what you can see. We draw the second graph because we've been told to draw the graph on the same axis. Again, we mark the points for y is equals to cos x. Let's mark. When x is 0, y is 1. So I will mark the point. When it is 60, 0.5. When it's 120, negative 0.5. When it's 180, that is negative 1. 240, negative 0.5. 300, 0.5. And 361. Again, we draw the graph by joining those points. It has to be a smooth curve. So that is my curve. That is my curve, which we are going to label it. We label this curve y is equals to cos x. Y is equals to cos x. So that is what you need to know. Just filling the table and drawing the graph, that should be a total of 6 marks. And so how will the marks be distributed in this case? Remember, you are told to use your suitable scale. So for the scale, you'll have 1 mark for the scale. And then for plotting, you'll have 1 mark or 2 because we have 2 graphs. This is 2. And then for the curve, you'll have 1 mark. So you see, at the end of the day, it's not about the curve. It's about following the right procedure and drawing it correctly. And in some cases, the scale mark may not be awarded, so that we end up with plotting mark 2 and then curve mark 2. So either the case, know how to draw a curve that involves trigonometric ratios. Part C of the question will entail solution. So part C, you'll be told, using your graph, and again, it's using your graph, not my graph. Solve sine x sine 60 120 0.87 sine 240 negative 0.87. That is for the first curve, so 0.87. So we'll simply change it here. So we have 0.87. And then again, the lower side, 300 and 240. This is 0.87. So we'll change this. So when the 2 points are now close together, then we shall have to get a common turning point. So in between, that is 90, and sine 90 is 1. So this curve should turn at 0.1. Again, this curve should turn at negative 1. So now when you draw the curve, it should turn this way. Yes, so that is now the curve y is equals to sine x. So using your graph, find number 1, sine x is equals to cos x. And number 2, you state the amplitude for each graph. State the amplitude for each graph. So in this line now, what we do is we use our graph. And from our graph, what we are having is we have said this, the amplitude is the maximum point above or below the x-axis. So what you need to do is to identify the maximum point for y is equals to cos x, and the maximum point for y is equals to cos x is 1. So the amplitude here, amplitude for y is equals to cos x is equals to 1. And again, the amplitude for y is equals to sine x will be equal to 1. If we are looking at the period in each case, the period for y is equals to sine x, y is equals to sine x. This is a half of the cycle. This is another half. That gives us 360. And then the period for y is equals to cos x, again, will be 360 degrees. And so we are left with part 1. And part 1, my students, what you ask is to get the value of x for which sine x is equals to cos x. Now, where the two graphs are equal should be the point of the intersection. So we only need to look at the points of intersection. And this is the first point of intersection of these two curves. And then extrapolate to read the value on the x-axis. You have to show the marks of extrapolation. Again, at this point, you extrapolate to read the value on the x-axis. That will be the point where the two graphs are equal. So you'll be able to note that the value of x will be 30 degrees and 240 degrees. That is the point where the two graphs will be able to will be equal when you draw the graph of y is sine x and y is cos x. So that is what we need to know when we are revising on graphs, trigonometric graphs. Know how to identify the amplitude, period, and phase angle without drawing the graphs. And number 2, when you draw the graph, how do you identify the 3 from your graph? Something that you also need to know is that when you're looking at the tan graphs, for the tan graphs, we will be drawing them, but only if we have a specific phase angle. A specific phase angle that will make that graph continuous at the points 90 degrees, 270 degrees, 540 degrees, and so on. And that is the only way we can draw a tan graph, so that the graph becomes continuous. Otherwise, the graph of y is tan x will be asymptotic, and in that case, it cannot be able to help us work out the amplitude, period, and the phase angle, because it will then have no maximum. It will also have no minimum value. We can have another graph. Okay. We can have another case, and this one is a calculation one. That is question 3. You're told determine the amplitude, period, and the phase angle of the amplitude, period, and the phase angle of y is equals to 3 cos x plus 45, and y is equals to 3 cos 45, and y is 2 sine 2x. That is part A. We are only determining the amplitude, period, and the phase anchor. So for each of the graph, our solution will be y is equal to 3 cos x plus 45. In this case, the amplitude is the coefficient of cos, which is 3. This is the amplitude. And the coefficient of x, which is 1, gives us the value that will be able to help us get the period, which is 360 over n. So in this case, it is 360. The coefficient of x is 1, so it's 360 degrees. And the phase anchor will be equal to 45 degrees. For the curve, y is equals to 2 sine 2x. The amplitude is 2. This is the amplitude. And then the period will be 360 over 2, which is 180 degrees. And in this case, there is no phase anchor, so it's equals to 0. The phase anchor is 0. So that is what we have to understand when we are solving trigonometric ratios graphs. So we will then need to look at some of the questions that you've sent so that we can be able to help you revise again. Let's see your feedback in terms of the questions that you've been able to send. Okay, one of our students is Levis. Levis from Tenges Boys says, can one give a phase angle negative value? No, we give the absolute value of the phase angle. Why? Because the phase angle is simply the angle difference. And so it's either we are adding or subtracting that angle. And so if we found, for example, y is equal to 3 cos 2x less 30, then our phase angle is 30 degrees, only that we are subtracting. So it can either be addition or subtraction, but now giving the phase angle, we give it as a positive value. Hi teacher, I'm Eva Washuka from Kirima High School. In 3, what we have is in 3 sine 2x less 45. Can we say phase angle is negative 45? The same question to question 1. The phase angle is 45 degrees, positive value, only that we are subtracting here to get the value for sine 3 sine 2x. So it is positive 45 degrees. This is a manual from Kisumu. When given y is 2 cos x and y is 3 sine x, then you are told to draw the graphs and use the graph to determine the values of x when 2 cos. Now when you're given these graphs to draw, it means draw the graph of y is 2 cos x and draw the graph of y is 3 sine x. You'll find if you draw these graphs, they will appear as this case. Let's take, for example, this is 0. This is a 60, 120, 180, 240, 300, and 360. So this is twice the graph that we have here. So now we shall have this is 1 and this is 2. So it will mean our curve will start from this point. This is -1, this is -2. And so it will run that way. This is y is equals to 2 cos x. And if you draw y is equals to 3 sine x, this is 3, and this is -3. The graph will run. This is how the graph will run. This is the graph y is equals to 3 sine x. And so what the student is asking is, you are told to solve. You are now solving 2 cos x minus 3 sine x is equals to 0. Now what you do is, this graph has already been drawn. Same to this graph. So if I take this to the right-hand side, then I will have a case of 2 cos x is equals to 3 sine x. And this situation is the same situation we have here. So where the two graphs are equal, simply means go for the points of intersection. Get the point of intersection of the curve. And so you get to this point and extrapolate to the x-axis, read the value of x. Again at this point, extrapolate this to the x-axis and read the value of x. That is good, Emmanuel. Gloria from Nakuru Girls, please pardon on determination of amplitude phase angle without a graph. When you're looking at the amplitude, period, and phase angle without using the graph, I've given a very simple principle. In this case, you'll be given the graph of y is equals to a sine nx plus b, or you'll have y is equals to a cos nx plus b. And so we are saying the amplitude is always the coefficient of the sine or cos, which is a, and then the period is given by 360 degrees. You divide by the value of n, and then the phase angle is the angle difference in this case, which is b. So that's how you work out Gloria without drawing the graph. Edwin from Nyamasaria Secondary, help me solve this. We have y is equals to sine 2x plus 40, and y is 2 cos x. You are supposed to identify the amplitude and the period of the two functions. Again, for this function, the coefficient of sine here is 1. So this is like saying 1 sine 2x plus 40. So the amplitude for this curve will be 1. The period of this curve will be 360 divided by 2, which is 180 degrees. And the phase angle is 40, phase angle is 40 degrees. For this one, the amplitude, the coefficient of cos here is 2. The period will be, the coefficient of x is 1. So it is 360 over 1, which is 360 degrees. And then the phase angle is 0. Phase angle is 0. So that's how you work it out, Edwin. Morning, teacher. I'm Emmanuel from Eldoret. Please help me this question. So you are given Emmanuel has a different aspect. We have 5 sine, I believe this should have been sine squared x plus cos squared x is equals to 2. His question is not about the graphs, but we are solving 5 sine squared x plus cos squared x is equals to 2. And so we have to use what we call trigonometric identities. And the first trigonometric identity, Emmanuel, which will be applicable here, is sine squared x plus cos squared x is always equals to 1. When you have sine squared x plus cos squared x, it will be always equal to 1. So what we'll do is, have sine squared x plus cos squared x is equals to 1. I will either decide to eliminate sine or cos. If I do with sine, then what I mean, I will take cos to the right-hand side. So it implies that sine squared x is equals to 1 less cos squared x. And so I will replace it here and have 5 into 1 less cos squared x add cos squared x equal to 2. By expansion, this is 5 less 5 cos squared x add cos squared x is equals to 2. Then collect the like terms. So this is minus 5 plus 1. That is minus 4 cos squared x is equals to 5 to the right-hand side. It is 2 less 5, which is negative 3. Then divide by negative 4, so that we have cos squared x is equals to 3 over 4. Cos squared x is equals to 3 over 4. So what we need to do is simply first of all, get cos inverse of 3 over 4. What is the cos inverse of 3 over 4? Sorry, we have 3 squared. This is cos squared. To get cos x, first get the root of 3 over 4. Square root of 3 over 4. The 0.8666. So that is cos x. So to get x, get now cos inverse of that value. X is the cos inverse of 0.8666. What's the value? 30 degrees. X will be equal to 30 degrees. But remember, from the question given by Emmanuel, we are supposed to give the values of x between 0 and 360. And so I know students are familiar with this cycle. And they know they usually use the abbreviation, all students take changa, but don't take changa. All students should take coffee. So if all students take coffee, let's use coffee is better. A means all angles. And all angles here are positive in the first quadrant. In the second quadrant, it means only sine is positive. That's why we have S, students. In the third quadrant, only tan is positive, take. And in the fourth quadrant, only cos is positive, either coffee or so on. So how do we get the value of x in the second quadrant? 180 less theta. Third quadrant, 180 add theta. Fourth quadrant, 360 less theta. That's how we get the values. So we will be able to get the values in the fourth quadrant, not in the second and in the third, because we are having cos. So it means the angle will be 30 degrees and 360 minus 30, 30 and 330. So Emmanuel, those are the solutions for x that will satisfy that equation. I think there is no more question. Okay. So now what we do is we can end our lesson at this point. And I urge students to revise well on trigonometry. Trigonometry is one of the topics that is lengthy. One of it is in Form 2, very long. Again, in Form 3, Trigonometry 2 and Trigonometry 3. Therefore, you have a lot to work on when it comes to trigonometry. For now, that's what you can do. Until next time when we meet again, thank you for being part of the lesson. I have been your teacher, Mr. Ndenga Elphas. Have a nice day.